Hello everyone. In today's video, we are going to see how to solve this particular question in the paper 2 series. We are at the 9th question and this is purely a non-right angle trigonometric question. Here a quadrilateral is given to us with the vertices ABCD and the length of AB, BC, all the sides have been provided, CD and DA. Now there are some sub-questions. Let's do one by one. Also, there is an angle marking we can see at B it's alpha and at D it's beta. So now first thing, find AC in terms of A, right? Find AC in terms of alpha, right? So let's start. First, we need to connect AC and I will get a triangle. It's a non-right angle, but still we know some formulas, right? So this formula, it's quite easy. We can refer the base of the formula, not the exact one. Let me show you the formula booklet now. Here. So it is provided over here. And which will be the best one to do this? Like we have sine rule, cosine rule, and area of a triangle. We're gonna select the cosine rule because I know the two sides. Like this is how that they have provided the triangle, right? This is my alpha. I need alpha to be included, and this 2, 4. I want this particular unknown. So in this case, you can just use cosine rule, right? And we don't want like cos of C. So we want AC. So let's apply this particular rule. Okay, right. And getting back to the solution page. Yeah, let's start with the formula. So how to convert if that is the triangular part? AC square is equal to, how to write, that is a fixed formula for triangle ABC, like normal labeling, but for us, we need to slightly change the formula. AC square is equal to the other sides, right? Like we are considering triangle ABC because that includes alpha. So AC square is equal to other sides, you have to square and sum that, minus 2 times the side of the remaining side. So 2 times, this is in the formula itself, and we need to put 2 into 4, the sides, times cos of the included angle of those two sides, right? So that is alpha. And that's simple. So AC in terms of alpha, let's go. AC square is equal to 2 square is 4 and 16, and you multiply these, you will get 16 again cos alpha. And it's 20 minus 16 cos alpha. AC square is equal to. So AC is equal to square root of 20. I ignored the plus or minus. I took only the plus part. And AC is equal to 20 minus square root of 20 minus 16 cos alpha. Right? So this is AC in terms of alpha. First part is done. Next part is very similar to this. We have to find AC in terms of beta. That's the next part. So same thing. Again, I want to include the AC, so let me connect A and C. But now I'm going to consider this triangle. Consider triangle ADC. It's quite easy because I want to include the beta now. So that's why we took this bigger triangle. And same formula, like AC square is equal to the other sides. 8 and 6 are the other sides. You square and sum it, minus 2 times those two sides you multiply, time cos of the included angle, which is beta. 8 square is 64, 6 square is 36, minus 120. Wait, here there's a mistake, just change this. This is actually 6, right? 8 times 6 is 48, and when you multiply, you will get 96 cos beta. Let me add them. This is 100 minus 96 cos beta. This is AC square. We want AC. and AC is equal to square root of 100 minus 96 cos beta. I can take 4 common out from this to simplify it further. So AC is equal to, when 4 come out of the root, right, it will become 2. And this is 25 minus 24 cos beta. So AC in terms of beta also we have converted. So simple direct formula and just basic simplifications. And next, the third part, hence or otherwise express alpha in terms of beta. We know AC in terms of alpha and AC in terms of beta. Now we need to express the angle alpha in terms of beta. Hence or otherwise means you can utilize the previous stuff or you can find some other different way. Okay, so how can we solve this? I know AC in 2 different ways, so I can equate them. This is one way and this is second way. Both represents AC. So let me equate 1 and 2. 1 and 2 are equal. When I equate, the first one says square root of 20 minus 16 cos alpha. The second one says square root of, I think it's, okay, 2 times the square root of 25 minus 24 cos alpha. Now, wait, cos beta. Now I want alpha in terms of beta. First, let's get rid of this square root. Let me square it on both sides. Okay, you are squaring along with that 2, which is multiplied before. So square root will get cancelled and you will get 20 minus 16 cos alpha is equal to 2 times, okay, 2 will become 4. 4 times 25 minus 24 cos beta. Okay, so this is 20 minus 16 cos alpha equal, we take the 4 inside, which is 100 minus 96 cos beta. Let me transpose like alpha in terms of beta we want, right? Let me keep the alpha on one side, like better to take it right. So 16 cos alpha and all other will shift here. So 20 minus 100 and then plus 96 cos beta. Okay, 96, we got this. 96 cos beta minus 80 equals 16 cos alpha. Let me divide by 16 on both the sides. It's divisible. So I will get 6 cos beta minus 5 equal cos alpha. I want alpha, right? So you take cos inverse. This will go as cos inverse. So cos inverse 6 cos beta minus 5. So alpha is equal to cos inverse 6 cos beta minus 5. So we have expressed alpha in terms of beta. That's the second part. Alpha in terms of beta. Alpha should be the subject, right? So that's simple. And next part. In this case, find the maximum area of the quadrilateral ABCD. Again, I'm going to split into 2 triangles. Area of triangle 1, like the smaller one. So the entire area of the quadrilateral is like that. Area of this first part and second part. Okay, how to find area in, we don't know height, no altitudes here. Let's get back to the formula sheet. So this formula, half AB sin C. So actually this is given, but we should know how to label this. This formula will work. It's like A and B should be, A is the side opposite to A, B is side opposite to the vertex B, and C is opposite to C. Angle C is the sine C. So these things, this is the way we have to interpret the formula. Yeah, you can refer this, and now we can get into the solution. First, consider area of triangle ABC is equal to half into, what are the two known sides? 2 into 4 and the included angle. So 2 times 4, sine of the included angle, which is alpha. Very simple. Let me simplify. It's 4 sine alpha. Then area of triangle ADC is going to be half into the two known sides and the included angle. 8 times 6 times sine beta. Let me simplify, which is 24 sine beta. So what is area of quadrilateral? Let me denote it with capital A, is equal to 4 sine alpha plus 24 sine beta. This is the expression, but I want what could be the maximum area here, right? So to maximize it, we always, because alpha and beta are two different angles, so either convert into alpha or beta. And we already know alpha in terms of beta, so let's choose it. That we are going to convert everything in terms of beta. Right? So the expression we have is here. Alpha can be written as cos inverse, where it is, that's the previous problem. Cos inverse 6 cos beta minus 5. Okay, so this will be tricky because when we apply directly, like 4 sine, in place of alpha, I should use cos inverse 6. So there will be a lot of function. Better we can choose in this way. We can apply an identity. Okay, in terms of sine alpha, I just want cos alpha, right? So a better way, so instead taking this final expression, we can take this. Cos alpha can be written as 6 cos beta minus 5. So let me start this and we can use it now. We know that these are all our working. So cos alpha is equal to 6 cos beta minus 5. Okay, but I want the replacement for sine alpha. I want to replace the sine alpha. Yes, I can do because we know this identity, sine square alpha plus cos square alpha equals 1. This is a very basic identity. It is also available in the formula booklet. Let me show it to you. The basic identity is over here. Here, cos square theta plus sine square theta equals 1. So this one we can apply. And let's get back to this solution page. So that means what will be cos alpha? Right, I need a replacement for sine alpha. So sine square alpha is 1 minus cos square alpha. I just want sine alpha. So it will be plus or minus root of 1 minus cos square alpha. We're going to pick the first positive since we are dealing with area. So no minus. So we finalized sine alpha is equal to square root of 1 minus cos square alpha. So my cos alpha I know, and this you can square it. So using that, sine alpha equals square root of 1 minus 6 cos beta minus 5 the whole square. We should be very careful here. This is an expression for sine alpha. Also, this is the simpler way. Now again get back to the area of quadrilateral and replace sine alpha with the work we got. And everything will be in beta now, right? So area of quadrilateral equal, what it is actually 4 sine alpha So 4 times 1 minus 6 cos beta minus 5 whole square plus 24 sine beta. Yeah, everything is in beta. So the area will get maximum. It depends upon cos beta and sine beta, right? And cos and the sine, okay, what is the maximum of cos? It's positive 1. Maximum of sine is also positive 1. But if I want both to be positive 1, I want beta to be 0 degree here and beta to be 90 degree here. But beta should be same. So in that case, we have to pick the value where cos beta, cos and sine is same. At which angle? At 45 degree, pi by 4. So substitute pi by 4. So both will be same, right? And also that's the maximum it can reach. So cos beta equals sine beta equals 1 by root 2. So this will not be available in the formula booklet. We need to memorize. Right. So this is the maximum possible. And we can replace cos beta and sine beta with 1 by root 2. So maximum area of quadrilateral. Okay. Let's substitute it and then which is equal to 4 times square root of 1 minus 6 times cos beta is 1 by root 2 minus 5 the whole square. Then plus 24 sine beta is 1 by root 2. So simplifying it further. Directly you can use calculator. That is totally good. Let's simplify. 4 times, it's not like 4th root. 4 times 1 minus 6 by root 2 minus 5 the whole square outside plus 24 by root 2. Now, this can be solved using calculator. Let's switch to the calculator page. Right? So the expression we got is 4 times under the root. So control and root. 1 whole minus, then an expression starts. And we need to square it. Which is 6 by root 2 minus 5 inside. So 6 by square root of 2. So control and then square root symbol and then 2. Okay, again let's use a bracket. Otherwise this will confuse. Like for 6 by root 2. Make use the parenthesis 6 by root 2 then a minus 5. Right? Whole square and get out of the stuff and plus 24 divided by root 2. Sorry. Control and root 8. (24 by) just a second. 24 by root 2. That's it. Let's hit enter. And we got 19. Okay, let's check our expressions are perfectly fit. So 19.586. This is our answer. Let's switch to that solution page. Yeah. Here we go. So this is approximately 19 point. We got 586. Let me put this up here. So approximately we can take 19.6 square roots. This is the maximum area. That's simple. And thank you for listening. Let's meet in the next video.